flows, bends, stretches, and squeezes.
It's chaotic and turbulent and going every which way.
It has a past, a present, and a future.
You can't see it, smell it, touch it, and yet it rules our lives.
And now scientists believe they know how to go backwards, forwards, and even sideways in it. Discover how the impossible is possible in time travel. Like a train on a track, time rolls relentlessly on. It is our friend and our foe. We need it, use it, and abuse it.
We're all passengers on the train of time, with a past, present, and a future. And whether we like it or not, we're all headed toward a destination at the rate of 1 second per second.
But what if we could control time instead of it controlling us?
I am talking about traveling through time.
If you could travel to any point in the time continuum, where would you go? What would you see?
If time travel were possible, what a fantastic journey we would see. We would see the rise and fall of empires. We would see the height of the Roman Empire. We would see the building of the pyramids. And we would see the rise and fall of the dinosaurs.
And if you could travel forward in time, where would you go?
I would love to travel to the future, 10,000 years from now, 1,000,000 years from now. What kind of technology do we come up with, given the exponential growth over the past 100 years? It's almost inconceivable what kinds of structures we might build and what kinds of gizmos we might have.
Movies like The Time Machine, Back to the Future, and Contact, as well as television shows like The Time Tunnel and Star Trek, have thrilled audiences with their time-traveling adventures for decades. But is the world of fiction about to become fact? Is time travel actually possible?
In physics, we have the expression, if it's not forbidden, it is mandatory. 100 years ago, physicists tried to disprove airplanes and heavier than air travel, and we failed. And now we realize that airplane flight, well, that's mandatory. So in other words, there's no law of physics preventing time travel.
It is the remarkable insights of the inimitable Albert Einstein that make time travel even conceivable.
Einstein developed two theories, his special theory of relativity and his general theory of relativity. His special theory of relativity allows for the time travel into the future, and his general theory of relativity allows not only for time travel to the future, but the possibility of time travel back into the past.
Einstein's special theory of relativity came in 1905. Contained in the theory that opened the door to travel into the future was an earth-shattering conclusion. Einstein discovered that time slows down for a person in motion as compared to someone who is standing still.
So in other words, here I am speeding on a train, and believe it or not, the clocks ticking on this train beat slower than the clocks outside.
The revolutionary concept was based on something scientists studying the nature of light in the 19th century had already proved, that the speed of light is constant. In fact, it travels at exactly 186,282.397 miles a second. But that's not all.
One of the things that scientists found completely strange was that light does not change. The speed of it doesn't change no matter how fast you're moving towards it or away from it.
This fact was the catalyst for Einstein's very special theory.
He was on, actually, a bus in Bern, Switzerland, looking at a mirror, and he was looking at his own reflection, and then he said, if this bus races to the speed of light, can I see myself?
The answer, Einstein reasoned, was yes. Because the speed of light is constant, whether one is moving toward or away from it, a passenger in motion, be it on a bus, train, car, or plane, can see their reflection in the vehicle's window. The image is, after all, made up of light beams, and he figured the reflection can be seen even at the speed of light. Why this is so is Einstein's true genius.
Nobody could figure this out until Einstein came and said that really what's happening is, the train got shorter and time slowed down.
If light doesn't change its speed, then something else must change. And Einstein said that something else is space and time.
Enshrined in Einstein's special theory of relativity, it was the key discovery that unlocked the secrets to time travel.
If you were to sum up Einstein's great theory of special relativity in one sentence, it would be this: time slows down the faster you move, in order that the speed of light is a constant throughout the universe.
Using a speeding train and the motion of the most accurate clock known to science, an atomic clock, which measures the precise vibrations or bounces of atoms, physicist Michio Kaku reveals the secrets behind the time dilation principle. First, Kaku sets up a stationary virtual atomic clock with a bouncing light ball denoting the passing time on board the train.
Let's say I have an atomic clock with two mirrors on it, so that light goes bouncing back and forth. Tick, tock, tick, tock.
Each vertical bounce of the light ball in the stationary virtual clock measures 1 second.
Now set it into motion on a train.
As the train moves forward, the bouncing light ball appears to move diagonally.
At that point, the light goes diagonally, and it looks as if light has speeded up. But that's impossible. Light travels at the same velocity. So something has to give. What gives is time. Time slows down.
Einstein figured that if you were looking at it from the outside, time on the train would appear to be slowing down. He also concluded that when in motion, strange things happen to space too.
The other oddity is that space contracts the faster you move. So in order to keep the speed of light constant, time must slow down and distances must contract as seen by a bystander. As the train begins to accelerate, it squeezes like an accordion. So if I'm riding on a train, I get squeezed, but I don't feel it. I don't see it because my atoms are compressed, my brain is compressed, everything around me is compressed inside a train.
Since a train's top speed is not even close to the speed of sound, let alone the speed of light, that time change is incredibly small. To see if time and space contract, as Einstein said they do, two British physicists in 1971, with support from the US Navy, devised a groundbreaking experiment. They took two highly accurate atomic clocks and put the time dilation theory to the test.
One clock was kept stationary at the Naval Observatory, the other was put on an ordinary passenger jet. They flew the jet around the world close to the speed of sound. When they brought it back, what they found was that the atomic clock on a passenger jet had lost time, it had slowed down.
It was about 50 billionths of a second slow relative to the one that had stayed on the ground, just as Einstein had predicted.
However, the really remarkable part is that if an astronaut is rocketing through space at super speeds, not only would the clocks on board the ship be slower than an identical clock on the ground, but, and this is crucial, so too would his heartbeat.
His heart would have to beat more slowly. Everything would have to tick more slowly on his spaceship. Time would have to move more slowly on the spaceship as you're looking at it.
If the astronaut's heart and all other processes in the body beat slower than that of the person on the ground, an awesome benefit occurs.
He must age more slowly. Otherwise, he'd notice that he was moving because his light clock was ticking oddly relative to his aging process. So everything on this spaceship would have to age slowly, and that's a result of special relativity.
And it is this slowing of the aging process in the form of a slower heartbeat for the traveler as compared to someone stationary on the ground that makes time travel to the future possible, in theory. But some researchers believe that huge leaps in science and technology could soon turn this theory into reality.
Echt een topmerk. Ideaal.
Stay.
I think we found something in there.
Secrets of the Underground. All new Tuesday on Discovery Science.
Einstein's special theory of relativity showed travel to the future is possible. If a train, plane, or rocket could, with the aid of yet-to-be-invented super technology, travel close to the speed of light, the future would soon come into view. Since the speed of light is constant, time would slow for the futurenaut and all his bodily functions as compared to someone left on Earth. Using this super high-speed technique to effectively trick time, it seems that a traveler can, at any point in the journey, step out of time as he experiences it and access any point on the continuum after he left.
How far into the future I travel depends on how fast I move. The longer I travel, and the faster I travel, the farther into the future I'll go.
But there is, as Einstein figured out, a universal speed limit.
As you approach the speed of light, time begins to slow down and maybe even stop. Distances contract in the forward direction.
Anyone with a massive telescope observing the intrepid futurenaut would notice some very strange phenomena. They would see that as time dilates or contracts, so too does space.
You get flatter and flatter like a pancake as you go toward the speed of light, and you get heavier and heavier until your mass becomes infinite at the speed of light.
Why this is so is immortalized in the most famous equation of all time.
That law is actually the one that every school child has heard. It's E equals mc squared. It says that a certain small amount of mass times the speed of light multiplied times itself will give you an enormous amount of energy.
And since the c in the equation, the speed of light, is constant, then as the energy of an object increases through faster movement, the mass must also rise.
E equals mc squared really says that as the speed of an object increases, its effective mass increases.
This means that the faster you go, the heavier the rocket gets.
So once the rocket's going fast, it has a lot of motion of energy, it's effectively much heavier, which means you need much more fuel to accelerate it further.
If the rocket were a train trying to reach the speed of light, it would be like adding an extra car for every 100 miles an hour you accelerate. Ultimately, the train at the speed of light would end up so heavy that it could not be moved. Logically then, it is impossible to move the rocket past the barrier that is the speed of light. This also means time would stop. So if you want to travel into the future, you need a rocket that can travel just shy of the universal speed limit. And surprisingly, that technology already exists. Today, in particle accelerators, like the one at Fermilab in Illinois or the CERN Collider in Switzerland, researchers have gotten close. They've been able to accelerate particles up to 99.995% of the speed of light. Since protons are the building blocks of atoms, and an astronaut's body is made of atoms, conceivably, it is also possible to launch him or her with all their equipment into space at 99.995% the speed of light.
Well, if you wanted to visit the Earth 1,000 years from now, 99.995% the speed of light going out and back, 500 light years would be enough. We send particles that fast today. So sending a person is just a matter of engineering and a lot of money.
Weighing an estimated 40 tons more than a single proton, the current cost of sending a human on a rocket ship into the future would be astronomical. But if money were no object, scientists say they can build the spaceship to do it. The trick is traveling as close as possible to the universal speed limit.
One way to achieve very high velocities would be a laser light sail.
Basically a giant mirror, the huge light sail attached to the ship would be unfurled in space. A giant laser, also positioned in outer space, would fire a massively powerful beam at the enormous light sail mirror, launching the ship and the astronaut into space and into the future. But there is a problem. The spacecraft would gradually slow down as it hits particles of interstellar gas. To compensate and keep the spacecraft near the speed of light for the entire journey, the energy would likely have to come from an antimatter engine. Antimatter atoms are made of electrons and protons with the opposite charges of normal matter. And when combined, matter and antimatter annihilate each other, producing the most powerful type of energy known to science, called gamma-ray photons. After 500 years, the futurenaut uses the slingshot effect of gravity around a distant star or planet, as practiced to perfection around the moon on countless Apollo missions, and turns the rocket ship around, zooming back to Earth. As the traveler gets close to home, he again unfurls the light sail mirror, and this time, the space-based laser fires at the ship as it approaches.
To slow down, to come back, you could use the matter-antimatter rockets, and then you could slow down again with the laser light sail.
And here is the fantastic part. According to the clocks on the ground, 1,000 years will have passed on Earth. At the same time, the clocks on board the rocket ship show only 10 years to have passed for the time traveler. The relativity of time has allowed him to travel to the future. But some physicists believe there's another way to visit the future, besides traveling at near light speed. As long as you don't mind getting up close and personal with a black hole.
Of the Underground, all new Tuesday on Discovery Science.
Like a running river, time flows relentlessly downstream into the future. The drops of water are like the seconds of a clock, quickly rushing by. The course the river takes, with its twists and turns, synonymous with life. And now scientists say we can, with the right technology, play with the flow of time and hurtle a traveler forward into the future.
Suppose one is paddling along the river in the direction of the flow. Then, in fact, one can get to a greater distance than if one were just going along with the flow. This is sort of like traveling forwards in time at a faster rate than is normally possible.
And there's another way to travel to the future besides hitting the accelerator. it's as simple as hanging out where things are heavy. Instead of traveling near the speed of light to slow down time and return to a future Earth, spending time around strong gravity does the same thing. And once again, it is the amazing discoveries of the original Titan of time, Albert Einstein, that unlocked this time travel secret. It came when he predicted that light beams curve and bend in the presence of large stellar objects, like stars and planets. This is the crucial idea in his efforts to combine accepted principles of gravity with his previous work on relativity, leading to his magnificent general theory of relativity.
The general theory of relativity says that space and time itself is like a fabric which can bend and fold depending upon how much mass you have at a given point.
Einstein figured out that this is how gravity actually works. To understand the concept, it helps to visualize a massive stellar object like our sun. Like a bowling ball on a rubber sheet, as it sits in space, it bends and warps the space around it. Now, add a smaller object like our planet Earth to the picture. We see that because the space around the sun is curved, our little planet ends up whizzing and bending around the sun in an orbit. Just like planets, light beams also are susceptible to the tug of gravity. They too actually bend as they pass large objects. Einstein also realized that if space is flexible, so too is time. Therefore, space and time were deeply intertwined. He even called it the fourth dimension. If space-time is one, then time itself, like a raging river, runs, warps, and curves at different rates in different places, too. In fact, like a river, the rate at which time flows depends on the size and shape of obstacles in its path.
So in a similar way, if you put a clock in a strong gravitational field, that's like an obstruction that causes the time to move more slowly.
It follows that if the time-warping properties of gravity can be exploited, then they can be used as a time machine to the future. To be really efficient and go way into the future, the best bet would be to use the biggest and baddest gravitational fields known to science. Those in and around a black hole. They are deep cone-shaped wells in space that radically warp and slow down time.
I'm in this gravity well, which as I'm falling towards it, is beginning to pull me apart. You may think that I have a problem, but I'm aging a lot slower than you are out there.
This makes the area near a black hole a perfect candidate for a future time machine.
If someone got close enough to a black hole, their clock would slow down to a point where only minutes may be passing for them. However, hundreds of years could be passing for everyone else.
The closest supermassive black hole to Earth is in the center of our galaxy. It's known as Sagittarius A star, some 26,000 light years from Earth. Even though we can't punch in a date and magically travel to that time like in the movies, the idea here is the same as traveling near light speed. We can journey to the future by slowing down relative time for the traveler, who can then join back up with the time that's kept racing along on Earth. Using state-of-the-art supercomputer animation, Max Tegmark shows us what a trip around this nearby black hole time machine might actually be like for a futurenaut.
We're looking here at the monster black hole in the middle of our galaxy, which weighs 3 million times as much as the sun. And it makes a great time machine for traveling forward in time.
If the futurenaut can navigate the turbulent waters around a black hole without getting too close or sucked in, he would be able to access Earth's far-off future.
All you have to do is steer very carefully because it's an unstable orbit. So if you mess up, that mistake will be your last.
But if a skilled traveler can maintain stable orbit and survive the ride, the experience would be spectacular.
You can watch Earth in your telescope, watch television from Earth while you're there, and everything will, of course, appear to be happening in fast-forward mode because your time is running slower. When you feel you've had enough, you gently turn on your rocket thrusters, start spiraling out of your orbit, and go back home to Earth. And when we come back home, we're going to be much younger than our old friends back here.
But traveling back in time is a much tougher proposition. To physically travel back in time, you would need to exceed the speed of light. And as Einstein proved in E equals mc squared, that is impossible. However, there may be a loophole.
The trouble with this is that Einstein showed you can't build a rocket ship that goes faster than the speed of light. But in curved space-time, you can beat a light beam by taking a shortcut.
This fantastic idea is based on what Einstein proved, that gravity curves space and time.
Well, in curved space-time, space and time can be twisted in such a way that although you're going toward the future, you circle back and visit an event in your own past.
If it turns out that this theory can be put into practice, it will have amazing consequences.
You could come back before you left on that journey.
It's a crazy-sounding notion, but this type of time machine is already under serious discussion, under a different name.
We physicists call this a closed time-like curves, or CTC. So if you read the physics literature, we don't say time travel, time machines. That's too embarrassing.
I am talking about traveling through time.
We say CTC in the physics literature.
Scientists believe they're closing in on a way to make a closed time-like curve, or CTC machine, work.
Perhaps, just perhaps, if we can assemble enough energy and matter, perhaps we can bend time into a pretzel.
If so, it will open the door to backward time travel. So what might a closed time-like curve machine look like? One radical design is based on the work of a young Tulane University physicist, Frank Tipler. In the 1970s, he mathematically proposed that if you had an extremely tall rotating cylinder in space, spinning at a rate of thousands of times per second, and close to the speed of light, you could create a closed time-like curve.
So that means that a rotating massive cylinder could cause the space to become twisted, and it causes time to become twisted into a loop.
If you could follow the path the twisted light beam makes on the outside, you would go back in time.
If you went around the cylinder in a proper way, you could again come back before you started. This is like a loop-the-loop on the roller coaster. The time traveler is always going toward the future, so he goes around this time loop and comes back to an event in his own past.
Tipler suggested such a cylinder could be as small as 60 miles long and 6 miles wide. Even if this idea could be made to work, there is a problem with this type of time travel machine. You can only go back to the time when the device was built. If you want to travel back even further in time, to any point on the continuum, you need to find a naturally occurring type of time machine. Some scientists believe the best hope for unlimited backwards time travel rests on objects which have never been seen, but are predicted to exist: cosmic strings. They are thought by some to have been created in the first fractions of a second following the Big Bang, when the universe was created. Cosmic strings are long and thin strands of high-density material that vibrate, putting out energy as they float and fly across the universe. Weighing an incredible 1 million billion tons per centimeter, a cosmic string 1 mile long would weigh more than the Earth itself. Trailblazing Princeton physicist J. Richard Gott believes their staggering density could enable strings to twist space and time. The recipe for time travel requires two of them. Like giant rubber bands, these infinitely long strings whip around the cosmos at enormous velocities, estimated to be over half the speed of light, and are thought to straighten out with time. According to God's calculations, like the whoosh of wind felt by a passenger as two trains pass each other, when two cosmic strings pass each other at half the speed of light, they generate so much energy that they distort space-time in very strange ways.
The cosmic strings warp the space around them, so it's kind of like a pizza with a slice missing. It's folded up into a cone.
When this happens, chunks of space, like pieces of a pizza that have been eaten, seem to magically disappear, and when folded up to form a cone, a closed time loop is created. In other words, a shortcut in time is suddenly exposed. Created by the two cosmic strings passing, the shortcut can be used as a time machine. It can cut a path through space that beats the path of a light beam.
If you lived on planet A over here and you sent a light beam to planet B, it could go through the center between the two cosmic strings. On the other hand, though, you could go on your spaceship on path number 1 and actually beat a light beam going through the center because you're taking a shortcut.
Imagine a trip with no travel time at all.
You could arrange it so you could leave planet A at noon, go around the cosmic string, go to planet B at noon, and then come back to planet A at noon. Now, planet A at noon is the same time and the same place, so you could say, hi, I've been around the strings. This solution allows time travel to the past.
But since we don't know how to create rips in space-time, we may have to find a naturally occurring wormhole instead. And physicists believe that the best bet for finding a wormhole time machine is in a set of conjoined black holes. Although there's still the problem of surviving the trip.
If you were to pass through the event horizon, then you're doomed. As you go toward a black hole, tidal forces begin to rip your body apart. In fact, even the atoms themselves are ripped apart, and you are spaghettified.
It's a one-way street, and there's no way back.
In fact, all matter, including light, gets sucked into a bottomless pit and eviscerated. But if, like a whirlpool in a raging river, the black hole was spinning, as mathematician Roy Kerr in the 1960s said they might, you could then jump in. He calculated that the centrifugal forces whipping around are so powerful, they can keep the throat of the wormhole open wide enough for a time traveler to enter.
This whirlpool is also analogous to a rotating black hole. If you had a rotating black hole and you jumped in, you might travel backward in time through the wormhole, especially if you had some sort of exotic energy to hold the wormhole open so it doesn't squish down on you.
So assuming for a moment that you could survive such a trip, Professor Gott proposes constructing this wormhole time machine close to a nearby star like Alpha Centauri. The idea here is that the intense gravity generated by a swirling wormhole would bend space so much that huge distances, and therefore time too, can be contracted.
You may have a wormhole mouth near the sun with another one near Alpha Centauri, 4 light years away. But yet, the distance between the two is a short tunnel. It's maybe only 10 feet long. So you can jump through this tunnel and immediately be on Alpha Centauri. You can beat a light beam going from the sun to Alpha Centauri.
And if one end of the wormhole can be spun fast enough, physicists argue it becomes a time machine. Here is why.
Suppose I have a wormhole with 2 throat openings, here and here. And now let's say I accelerate this one.
If you wanted to go 10 years into Earth's past, you would spin one end of the wormhole at 99.995% the speed of light for 100 years.
clocks moving that fast will tick 10 times slower than ones on Earth.
Now, if you jump into the opening that had been accelerated, you come out of the other opening at a time earlier. In other words, you travel backward in time. That's really weird.
10 years from now, they could come through the wormhole and come out the wormhole and see themselves coming into the mouth of the wormhole.
Since naturally occurring wormholes may have been created in the earliest moments of the universe, there may be no limit to how far back a traveler could go using one.
Perhaps there is a collection of positive and negative energy left over from the Big Bang, which is natural and naturally connects you to some place in the distant past.
There are, however, skeptics. Even if a naturally occurring wormhole can be located and retrofitted to be a time machine, some scientists say it is impossible to go back in time. The primary example of the problem with backwards time travel stems from a violation of causality known as the grandfather paradox.
What happens if you go backwards in time and shoot your grandfather before you're born? How can you be born?
Now, I hope I wouldn't kill my grandfather, but in principle, I could. And in that case, I couldn't possibly exist in such a way as to make that journey. How do you get around that paradox? That's a real problem.
But what if there were more than one universe and more than one timeline?
On this train, we're going down a rail. But that rail is like a timeline. We have the past, the present, and the future. However, this rail can also split into two rails, into two timelines.
If many universes and multiple timelines really do exist, then travel to the distant past, the far-off future, and even an alternate present are all in fact possible. And to understand how this mind-boggling concept works, potential time travelers need to take a close look at the tiniest matter known to humanity.
Science.
Time travel to the future or the past presents many theoretical challenges and technological obstacles. But some of the greatest barriers exist in our own heads. Time travel forces us to confront mind-boggling possibilities and to rethink the natural assumptions about the universe we live in.
If you were to just use Einstein's theory of gravity and build a time machine, you really do have a paradox. You can go backwards in time, meet yourself before you enter the time machine, and perhaps kill yourself before you enter the time machine. Well, that's preposterous, right?
But there is a place where even the preposterous just may begin to make sense.
The solution may reside in the quantum world. In the quantum world, we have electrons that can be two places at the same time.
The notion that a particle, such as an electron, can be in two places at the same time is enshrined in a theory made famous by a 23-year-old German doctor in the 1920s. It is the Heisenberg uncertainty principle. And this bizarre effect is at work in objects we use every day, like computers, radios, and televisions.
In electronics, transistors and lasers and diodes, they are all based on the quantum theory. And the quantum theory is the most bizarre theory ever proposed in history. Electrons can dance around, be two places at the same time. Electrons can disappear and reappear someplace else. These are preposterous for large objects, and yet they happen all the time inside a laser beam. They happen all the time inside the internet.
This seems illogical. how can an electron be in two places at the same time?
One way to resolve it is that there are parallel electrons. One electron here, another electron there, living in different parallel universes. And this gives us the possibility of multiple universes, a multiverse of universes.
If an electron particle can be in two places at the same time, so too can a person. The thinking here is that every time a decision is made, whether it be to turn left or turn right, or even to travel back in time and kill your grandfather before you're born, the universe, like a speeding train, can switch tracks.
It's like a railway switching yard. Every time you go into the past, let's say you killed your grandfather, that would just cause the universe to go off onto another parallel universe where there's a dead grandfather and a time traveler from the future. The world where you started out, that would still exist. It's another parallel world.
So if such parallel universes exist, time travel to the past would be safe. This is because in each new world, an entirely new and different history would unfold.
There's a parallel world where World War II never happened. All these parallel worlds are existing together.
If this concept is true, then all bets limiting time travel are off. Like a train that can go backwards, forwards, and switch tracks, travel to any time and place on the continuum is possible. And as the many amazing discoveries in the field of time travel continue to unfold, some scientists have been inspired to imagine, design, and even attempt to build their own time machines. Physicist Ron Mallett has a prototype. His idea is predicated on twisting light beams to create a closed time-like curve.
If space is being twisted strongly enough, what will happen is that space will twist time into a loop. So that loop in time, I will be able to go from the past to the present to the future, and along that loop, I can go from the future back into the past.
The concept is, according to some, far-fetched and mathematically implausible. Undaunted, Mallett forges on. His controversial concept is based on the notion that light, fired in a circle at super speeds, will eventually create enough energy that it will warp space. And, as Einstein found, that would change time, too.
The thing is that even though light doesn't have mass, light does have energy. Remember E equals mc squared? That means that light can also create gravity through the energy of light.
With a mug of coffee and an espresso bean, Mallett shows us how his laser light warping time machine works.
You can think of space as being like the coffee in this cup. And a circulating light beam, in my theory, is like the spoon. So what happens if I stir the coffee with a spoon? It swirls around. Well, that's what the circulating light beam is doing to empty space. It's stirring it around in the same way. Now, if I put a coffee bean in, then I can see that the coffee is dragging the coffee bean around. That's what will happen in empty space if I put a subatomic particle called a neutron, which would act like the coffee bean.
Mallett calculates that he will eventually need some 10,000 high-powered lasers configured in a circle, as in the model, to create a potent time loop. Then, before he sends a human time traveler, he plans on sending a tiny neutron, measuring less than the width of a human hair, back in time.
What we're looking at is subatomic particles and information. So if we send a particle, a neutron, through that, we should be able to see this space twisting effect. What we hope to learn from the space twisting is what will be necessary to generate the energies for the time twisting.
Only then will the laser light time warping device be ready for prime time, and human trials might begin.
The question arises, well, what is the practical use of a time machine? One of the things that it could be used for is an early warning device. Imagine if we had a way of being able to predict future disasters, for example, an earthquake that's going to occur, and to warn ourselves of that, the thousands of lives we could save.
One day, these time travel dreams may come true, science may allow us to rocket time travelers into the far-flung future. Or, through fantastic leaps in technology, engineers may be able to construct a wormhole that can be used as a time tunnel to the past. It's also possible that quantum physicists hold the answers, and that many worlds and parallel universes exist, offering an unlimited number of different pasts, presents, and futures. If scientists are right, then fiction may someday become fact, and the impossible will suddenly be possible.
Time travel could lead us to the possibility of altering our destiny in a way that we had never dreamed of before. It could lead us to a whole new golden age of humanity if we use it wisely.